HP， 前提不必的 HC。And the HT to be the HI, right? In this way, okay? Well, this is HI, this is HC, this is also HC, alright? Now, here, it show, on the right hand side, show the schematic diagram of the piling up. And then on the left hand side, this figure, the half part, show the sinking behavior. Now, this is a deformed surface. After deformation, we have to show the solid curve surface, alright? And the dash curve is just the ideal case, meaning it's the ideal backwards indenter, meaning your indenter is just the shaft in after the tube, okay? So, if you create by the ideal indenter, we have the areas look like this one. It's surrounded by the dash straight line, okay? But in reality, you obtain your real contact area, mean the actual contact area is the solid curve surrounded by the solid curve, okay? If it's operating in the sinking case, you will find that your real contact area obtained in your real case is smaller than the ideal case. Your ideal case, how the contact area predicted by the ideal case is much larger than the real contact area. This is in the sinking case. If you're operating in the piling up material, you'll find that your area created by the ideal case is smaller than your real case because you have a piling up. Your piling up have the HC value larger than your HI value. Okay. In this case, the real contact area is much larger than the ideal indenter area. Okay. So that is because we use the real contact area to evaluate our material property. So in this case, you use the ideal case is just 24.5 HC squared. Alright, this is the ideal case. But you have an additional term to modify it. Okay. So in this case, either the sinking case or piling up case, if we don't have the additional term to improve our accuracy of the real contact area, we'll find that they have a bigger error. We have a bigger error. If we don't have a make we use the ideal case, ideal contact area as our contact area, we'll find the bigger error we create. Okay. So there is piling up and sinking in. As I have mentioned many times that you use this additional term to modify your solution. Okay. But you will find this modified form also have the error. But the error is depend on material is the brittle material or is softer material. If it is brittle material, this modified real contact area have a small error. 你在印的材料的时候，这个修正过的这个模型所得到的结果会有比较小误差。But if you operating in the softer material, you will find a bigger error cannot be avoided. Okay, even when you have the modification term for your real contact area. Okay, 所以在比较软的材料你的误差会比较大。Okay, here, okay, if you operating, y is the yielding stress, epsilon is your strength. Sorry. Epsilon is your strength. E is your Young's module. Here, if you're operating in the elastic deformation area， 你作用在这个弹性的一个模式的时候 ，you'll find that your stress sigma and then your strain epsilon they have the linear proportionality. I mean the sigma equal to E times your E is your Young's module times your strain. Okay, or I think that the stress and the strain they are linear form. Okay, they are linear proportionality between these two parameters. But if you're operating in the plastic deformation, you mean that your epsilon is larger than this ratio, then your stress and the strain, you give this form. This form give the n is no longer to be the one value, no longer to be the one value. Okay, it's no longer to be one. Okay, so it is non-integer. Okay, 它不是一个整数，不是一个整数。So from these two equations, we can obtain the k and the e have the relationship like this one. Here y is the yielding stress. So k and then e have the relationship is obtained from these two equations. Okay, so this is piling up in a single. 我们休息一下，关掉。